So this is the code that I will use. So my variable x, what I'm gonna do is I'm gonna take all the rows, so all 200 customers, but I'm gonna isolate only column 3 and 4. Yeah, 3 and 4 are the two last columns. Remember, we start to count from 0. So let's run this code and let us check if it has done what we expect it to do. So if we do print x, we should see, and here you go, 2 columns. And here we see 1539. That's exactly what we have here. So x is correct. And the next thing that I want to do is import the necessary libraries, the k-means library. And we should write the code to look for the best k to apply. So let's paste this new block of code here. And here what you see is that I'm going to import k-means, of course. And I'm going to open an empty list, and this list is WCSS, which is the famous within cluster sum of squares. This is basically your cost function. And here you see at the end, you're going to append this to the list. Yeah? Meaning the inertia is going to be your cost, and you're going to add it to the list. And then you run a for loop for I from 1 to 11, and that's basically your k value is going to go from 1 to 11, because here you see number of clusters is I. So I'm going to run the k-means model. Number of clusters I leave as a variable I. Init is random. That means that we're going to initialize randomly, but we will also take the samples as the centroids. Yeah. Maximum iterations is 300. That's the default value. So we should be able to converge in 300 iterations. And then we have here and init is 10. And basically what that means is that we will use 10 different set of values to initialize. Yeah. So this helps us to get to deal with the problem of initialization and getting into a local minimum. Yeah. So here we will have 10 different initialization sets. Random state, of course, allows you to rerun that code and end up with the same values, because you have a random process running here. If random state is not 42, then the problem is that every time you will run it, you will get a different result. So in here, that's just plotting the case versus this within cluster sum of squares. So let's run the code. And here we are. It's easy to see that the number of clusters we should choose is going to be 5. Yeah. Here you see a knick in this curve. So now we can actually run the model with the correct number for k. Yeah. So we call this model, and here you see number of clusters is 5. And I calculate what k means by doing a model fit predict. Yeah. So what basically the output is for the fit predict x is the index of the cluster that specific point belongs to. Yeah. So it returns a cluster index for each of the pair's annual income spending score. Yeah. So let us go to the final block of code here, where we basically gonna plot the results. So here, the way to read this is a PLT scatter a function. And what you have is the y means equals 0. That means that the index of that certain point is gonna be 0. Yeah. And the second 0 here is the means the first column. Here you see exactly the same, but the second, behind the comma, you see all ones. So that's the second column. Yeah. So in each of these columns, you have points that have the outcome yk means 0, 1, 2, 3, or 4. Yeah. So you have 5 options. And the same here for the second column. S is just the size of the dots in your plot, and C is the color. And then we have some specific labels here as well. So let's plot this. Oh, problem. Oh, yk means it's not defined. I probably forgot to run this piece of code. So let's restart. Let's do it again. And here we are. Yeah. So basically, you have 5 clusters, and the red cluster here in the bottom left corner is people with a low income that don't spend a lot. Yeah. Which is probably where you need to be. If you don't make a lot of money, you should not spend it. Yeah. While the light blue here on the upper left corner are people with the low income but with a high spending score. Yeah. The purple on the top right corner are people with high income and high spending score. Yeah. These are probably the people you need to pamper. Yeah. And then here the blue are people that make a lot of money, but they don't spend a lot. So here are your thrifty people. Yeah. And then you have green in the middle, and green is the kind of average. Yeah. They make an average income or a lower average income, and they have an average spending score. So here you see that, and let me run all to see how long it will take. So it goes very fast. Yeah, it goes very fast, and with just a few lines of code, we have basically we're at 19 here. Yeah. Okay, that was it for clustering.